Could dropping a nuclear bomb on Mars actually make it habitable? It sounds like science fiction, but some scientists believe it might be a way to jumpstart a new atmosphere. In this video, we're breaking down the wild science, potential risks, and the reality behind the idea of nuking Mars to make it more like Earth. Let's dive into what might happen on the red planet. Terraforming, making Mars more Earth-like, is often suggested to warm up the planet and potentially release gases that could thicken the atmosphere, creating a greenhouse effect. Mars has a thin atmosphere, primarily of CO2, and detonating a nuclear bomb would add radiation rather than help with the composition. It could release some CO2 trapped in polar ice, but probably not in sufficient quantities to create a stable atmosphere. Even multiple nuclear detonations would likely not release enough heat to create sustained global warming on Mars. Mars has no magnetosphere or thick atmosphere to block solar and cosmic radiation. Adding nuclear fallout would increase radiation exposure for future human missions and potentially contaminate any natural resources, like water. Using nuclear detonations to create caverns for human habitats might offer some shelter from surface radiation. Controlling underground nuclear detonations to create stable, safe caverns is extremely difficult. Even on Earth, the resulting cavities would likely be radioactive, making them unusable for habitation without extensive cleanup. A nuclear test on Mars could potentially be part of an experiment to understand nuclear effects on Martian soil, or test theories in planetary engineering. We have more controlled, safer ways to simulate planetary conditions in labs on Earth, so the knowledge gained might not justify the risks and costs. This would likely face significant resistance on Earth due to ethical considerations about contaminating other worlds with radiation. Nuclear fallout would leave radioactive isotopes in Martian soil, posing a long-term risk to human explorers. Mars's low gravity means any gases released would likely escape into space quickly, rather than form a stable atmosphere. An international treaty, the Outer Space Treaty of 1967, already discourages nuclear weapons in space and would likely lead to legal challenges. Transporting a nuclear bomb to Mars is itself a monumental task. Nuclear devices are highly regulated and heavy due to their shielding and safety features. Given that it takes months or even years to send payloads to Mars, each kilogram of weight is costly. Creating a controlled, targeted nuclear detonation on Mars with precision to avoid catastrophic, unintended results would require sophisticated engineering, possibly beyond what current space technology can handle reliably. If there's any accessible water on Mars, likely as ice, nuclear fallout could contaminate it, making it unusable or unsafe for human consumption or agricultural use. This would compromise one of the few resources that humans might otherwise rely on for survival. Martian soil, or regolith, could absorb radioactive materials from a nuclear blast, potentially making it toxic for any future efforts at cultivating plants or mining for resources. The soil might also become too dangerous for astronauts to work with directly. Mars is known for its intense dust storms, and a nuclear explosion could exacerbate this by ejecting large amounts of dust into the atmosphere, which could block sunlight, decrease surface temperatures, and create hazardous conditions for equipment and habitats. Some scientists propose that crashing ammonia-rich asteroids into Mars could add nitrogen to the atmosphere, thickening it and adding greenhouse gases without the risks associated with nuclear fallout. This method would be a challenge to engineer, but may be more viable long-term. Large mirrors, positioned in orbit around Mars, could reflect sunlight onto specific regions, warming them and releasing trapped CO2 and other gases in a controlled way. This method, though futuristic, avoids the contamination risks of nuclear detonations and can be precisely controlled. Creating closed-loop greenhouse habitats could allow humans to live on Mars without drastically altering the planet's surface. These structures could produce oxygen and food in self-contained ecosystems, offering a safer, incremental step toward Martian habitation. So in summary, while the idea of nuclear detonations on Mars is a dramatic and imaginative concept, the drawbacks likely outweigh the potential benefits. Future Mars exploration and potential colonization are more realistically aligned with strategies that use the planet's natural resources more carefully and avoid contaminating the Martian environment with radioactive fallout. Science fiction has often popularized the concept of nuking Mars for fast fast results. But in reality, a slower, more sustainable approach may ultimately be the key to making Mars a second home for humanity.
If you enjoyed this video, make sure to hit like and subscribe for more awesome space content. And don't forget to turn on the notifications so you never miss an episode. Thanks for watching.